All right, so this example says that Forever Cell Battery Company analysts conducted tests on the life of its 9-volt batteries and those of a competitor brand X. They found that their batteries had a mean life of um, 26.2 hours, with a standard deviation of 4.1 hours. The result for the sample of 10 similar 9-volt batteries from brand X showed the following results. Okay, so they tested these batteries and they got these values for the number of hours that they lasted. And the first question is just asking us to find the mean and the standard deviation of this sample of brand X batteries. All right, so let's just put this data in the table. Our outcomes are, now it looks like they've nicely put them in order for us, so that's good. We don't have to put them in order. So 15, we have 18, and I could also put down, while I'm doing it, I could just put the frequency of occurrence. Um, but it happens, it looks like they're all happening once, except for to 25. Okay, so I'm just going to write down what I've got here. So 19, 23, 25, but this one happens twice, so I have to keep that in mind. 28, 30, 34, and 38. Okay, so those are all the battery lives that we have, and basically each one of them happens once out of 10 times because we have a sample of 10 batteries. All right, so we actually have 10 different measurements here, but one of them happens twice, and that's this one. So 2 out of 10 would be the probability of the 25, which is 0.2. All the rest of them are just 1 out of 10. We just have 1 out of the 10 values of each of these other ones. So we just have 1 out of 10. 1 out of 10. 1 out of 10. 1 out of 10. Okay, I could write that as a decimal as well if I want to. But so let's. All right, so now I've written all of their probabilities as a decimal. It's essentially they're all 1/10 except for the one that happens twice, which is 2/10. All right, so the next thing we need to do, we need to find the mean, right? And we're going to do that by taking the probability weighted average of these outcomes, which is also the expected value. Okay, so I'm just going to multiply these values x times their associated probabilities. So basically just move the decimal point one place to the right, or to the left, I mean. So this is 1.5, this is 1.8, this is 1.9, this is 2.3. Now this one we're going to multiply by 0.2, so then we get 5.0. The rest are just basically 1/10. So so this one's 2.8, 3.0, 3.4, 3.8. All right. And now to get the expected value, or the mean, same thing, we're going to add those up. So our mean is 25.5 hours. Okay, so that's the average battery life for brand X. All right, so next thing we need is the deviations from the mean. We're just going to take each one of those outcomes and subtract 25.5 from it. So minus 10.5, I get minus 7.5, minus 6.5, minus 5. No, not 5. Looks like that's going to be 2.5, minus 2.5. This one is minus 0.5. Let's see. Then we have then we have values that are greater than the mean. So this one is 2.5 above the mean. This one is 4.5 above the mean, 8.5 above the mean, and then 12.5 above the mean. All right. Next step is just to square the deviations from the mean and multiply by the probability. So make sure you grab the right columns, okay? It happens a lot that people grab the wrong columns when they're doing this. So we're going to square the fourth column and take it times the second column. Okay, and when I do that, I get 11.025, 5.625, 4.225, let's see, 0.625, 0.050. Let's see, the next one is 0.625, 2.025, 7.225, and finally I got 15.625. Okay. And then when we add those all up, what we get is the variance, right? I add those all up, I got 47.05. Okay. So the units were hours, right? Of the outcomes were in hours. So now this is in square hours. So to get the standard deviation, we're just going to take the square root. We're going to take the square root of 47.05. Square root of the variance gives us the standard deviation, which is 6.86 hours. All right, so now we have the standard deviation and we have the mean. The next question asks, which batteries have a more uniform life? All right, now we've got our standard deviation, right? The one that's more uniform is going to have the lower standard deviation. We calculated the standard deviation of the brand X to be 6.86, and we're told up here for the forever cell batteries, their standard deviation is 4.1. Okay, 4.1 is less than 6.86. So the forever cell batteries have a more uniform life. All right, so because their standard deviation is smaller, the forever cell batteries have a more uniform life. The next question asks which batteries have the highest expected life in hours. Okay, so we want to look at the expected value for the life of these batteries. And we calculated the brand X was 25.5, and we're told that the forever cell, their expected life has a mean life of 26.2. So the expected life of the forever cell is 26.2, which is greater than the brand X. So, hey, that's good. If you're working for forever cell, your batteries are better. So the forever cell batteries have a higher expected life. All right, so the expected life is the expected value for the life of the batteries, right? So the forever cell batteries have a greater expected life. So, hey, that's good. All right, well, I think that's all of the examples for this lecture, and you can look ahead at the discussion questions, and I'll see you in class.